All right, let's start. So welcome again to this webinar of What's New in SCIA Engineer 22. We will give you a brief overview of all new functionalities in version 22, as was also shown on the digital conference. First of all, some technical information about using GoToWebinar. The attendee audio will be muted during the presentation, but you can use the questions box to ask questions during the presentation. We have a colleague and myself to answer your questions, so don't hesitate. And the webinar is recorded and will be posted on the SCIA YouTube channel. So, what is new in SCIA 22? What will we show you? There are some user interface improvements. There is shear center eccentricity available, which means you can calculate torsion in the cross-section. We have 3D wind load engine improvements. The surface loads viewer is now available in 64-bit. We have an updated traffic load library. There is concrete member data automation, concrete reinforcement auto design for SLS, concrete 2D ULS capacity check, and concrete reinforcement design templates for columns. The AISC steel code check is available in 64 bits, as well as some CLT orthotropy input. There is the SCIA design forms in a new interface, and more. Good. So, as said, it is today a bit of an overview webinar, but we have some more detailed webinars on specific topics. You can find those on the website. If you go to support and services, and then you can see webinars and join a webinar. Here you can find some other topics that are planned. So, for instance, what's new in concrete, SCIA Engineer 22, the new Eurocode wind load generator, and the effect of considering shear center and eccentricity. So please don't hesitate to also join these webinars. That's it for my introduction. So I will not let you wait any longer, and let's go ahead with the demonstration.
Hello, my name is Martijn. As you might know, I work on support at SCIA, and I'm going to talk a little bit about the new things in SCIA 22. The first one is going to be the surface loads result instance. So you might already know this from previous versions as the 2D data viewer. Now we put it back in SCIA 22 as the surface load viewer. So I made a little example of a ground retaining wall. I also made some geological data to automatically generate the loads on this wall. And here you can see I made 2 layers, and the water will be at a height of 2 meters from the 0 level, which means that there will be a difference in wet and dry weight of the ground, as well as the water load that is going to be generated on the wall. I've already made 2 load cases, one for the ground and one for the water, and I will now apply a surface load on the wall of type soil pressure with a coefficient which is the active coefficient of the ground. I'm going to put it at 0.3 and just simply select the wall. Same thing for the floor slab, but here the coefficient will be 1, as this is just the weight of the ground. Next thing, I'm going to do the same thing for the water. So I'm going to switch the load case to water. And again, I apply a coefficient of 1 because the horizontal pressure of water is the same as the vertical pressure. And I'm going to switch the type to water, obviously. The problem in the past was that you couldn't really see what SCIA was generating in the background, while in the new version of SCIA in 22, you can see this with the surface load result instance. So I already put this result instance in my process toolbar, but you can also look for it in the command bar or the SCIA spotlight, and then simply drag it on the place where you want it in your process toolbar. If you then enable the result instance, you have to choose a type of selection. I'm going to do this for the wall at first. And I'm going to look at the load case ground to see which kind of loads are generated in the background. So if you look at this for the floor slab, it will be one value because it's just the weight of the ground. And if you go to the drawing setup, I can choose a color to decide which kind of gradient color you will see in the legend. Let's do the same thing for the water load. And there you will see that the first 2 meters starting from the top have no loading on it. And the reason is because I set the water level at 2 meters in the geological data. And you might expect a value of 20 on the bottom, but the reason is that we always show the resulting first in the middle of the mesh element. So if I want to have a value closer to 20 at the bottom, I have to lower down my mesh settings, and then you will see that I have a value that is closer to 20, which is 10 kilonewtons multiplied with 2 meters. So again, I'm asking for the same result instance, and now you see a more smoother result and also a value of closer to 20 at the bottom. This is just one example. Another one could be a building that you build up of 2D elements or load panels, and now you want to see the net pressure on those walls, for example, and you can do that with the surface load viewer. So I already generated some load in this model. And now I'm going to look at the wind load in the first direction along the x-axis. And now you can clearly see the positive and negative values because they have a different color. So it's easy to understand from what direction the wind is coming. So in this case, from negative x direction, the wind will be blowing. And you can clearly see that with the red surfaces. The blue surfaces, they have a suction load, so it makes it very visible from what side the load is coming. And you can now also see the net pressure of the wind, which wasn't available in previous versions of SCIA. So that's very useful with this new feature. Okay, so besides that, we also did some improvements to the 3D wind generator itself. I made a little example to show you which ones those are. This is just a steel hull with some load panels, some openings, and some awning on the back. And I already generated some wind loads in these load cases. So the first improvement is that we also show a different color depending on whether the load is a suction or a pressure load. So you can see that pressure loads in this case are blue, and the yellow ones that cause suction on the 2D element, which also makes it very visible from where the load is coming, X or Y direction. And there's also a separate setting in the color settings to decide what the color is for pressure and for suction, as you can see in these settings. Next improvement is that from now on, you can also show the net and peak pressure within a label on the 2D element. So first of all, the peak pressure, you can show it with these options. And afterwards, well, you first have to calculate. And afterwards, we multiply this peak value with the internal and external pressure coefficients to get a net value of the pressure on a certain 2D element. So if I switch to net pressure, that's also a value you can show in version 22 from now on. Next thing is that we also provided an option to take into account openings in the 3D wind data. I have an opening of 5 to 2 meters in front of my building. And if I click on the 3D wind data, I can also tell SCIA that it has to take into account this opening in the calculation of the internal coefficient for internal pressure, actually. So that's something I can enable in the opening itself. I fill in the area of the opening. And now when I perform my calculation, you will see that the internal coefficient for the pressure will rise from 0.2 to 0.35, as you can see. Which means that SCIA takes into account openings from now on. You just have to enable it in the wind data itself and not only draw it on the panel. Next thing we did was adding some types to the 3D Wind data. For example, this awning on the back. The only thing you need to do is set the correct type in the 3D Wind data. So in this case, it's just awning, and that's the only setting you need to do. I will run the 3D Wind generator once more, so you can see that now also some loads are generated on this awning. The only thing is that there's only described in the German, French, and UK standard how this load should be calculated. So whenever you use the standard approach, it will be calculated according to the German national annex. But as you can see, the loads are being generated, calculated based on the national annex you chose. And also the color of the load is related to the sign of the load, positive or negative. Another type we provided in version 22 in the types of structures in the wind data is a canopy structure. So the Eurocode also describes how these canopies should be loaded. From now on, you can generate loads on those kind of structures in SCIA itself. So I made a little example of a canopy with two slightly inclined panels. And that's also a setting you need to do in the wind data. So you have to set the canopy type and also the blockage ratio, which is described with a phi factor. You have to fill in, which is also described in the Eurocode. So then I will show you how these loads are generated, but it works pretty much the same way as a standard building. So you simply run the generator and then the loads are generated. And again, you can see the color changing for negative and positive values. So, okay, here's a positive wind pressure and you can see it turning yellow in this case. We also did some improvements to the interface in version 22. And the first one I'm going to show you is that from version 22, whenever you do a new command, the SCIA spotlight on top will automatically be activated and highlighted. So in the past, in version 2021, you had to first hit the spacebar to activate the command line, and then you can enter some values in there, which is not necessary anymore in version 22. So if I want to copy this frame, you can see that automatically the command line is activated and I can fill in the value between the frames in this case right away. So I don't have to hit the spacebar each time when I want to enter a value or a string in this command line. Another thing we added is this repeat option. And by default, the enter key is assigned to this repeat option. So what happens in SCIA now, every action you do is memorized. And if you want to repeat that action, you simply have to hit the enter key in this case, or the key you assign to this command. So for example, if I want to break these beams in the middle, and I want to repeat this command, I can simply hit enter instead of me looking again for this command break and define points. So right now I can simply hit enter key and I can also break the rest of the beams in the middle without having to search for that command each time. So this is also to improve your workflow a little bit. One other thing we changed is that from now on in this drop-down menu of the loads, you can also work with your arrow keys. So that was not possible in version 21, while it is in version 22, which makes it very easy to see what kind of loads are in the different load cases. So I'm going to put some line loads on these frames, for example. A line load of, let's say, 1 kilonewton per meter in this case. And I'm going to put some other line loads in the other load cases. And again, I can use the enter key right now to simply run the line load command again. So I don't have to look for the command. I can simply use the repeat option. Let's put some more loading in load case 3 with a different value of 3, for example. And maybe one more time in load case 4. With a value of, let's say, 5 kilonewton meter. And what I can do now is go to the drop-down menu and simply use my arrow keys to change between these load cases. And it makes it very easy and quick to see what is in a certain load case. One other thing we changed is that when you have a project with a lot of load cases, then sometimes you have to scroll a lot. And if, for example, a load case all the way down was activated and you want to go back to that load case, what you had to do in version 21 is scroll all the way down. And that's not necessary anymore in version 22, because from now on, this location will be memorized. And if you click on the drop-down menu again, it will be the one on top. So this load case 21 now is the one that is highlighted on top, and I don't need to scroll down all the way to look for that load case again. So that's also a pretty nice improvement when it comes to your workflow. I'm going to calculate this project. Okay, I first need to do some changements to the supports, apparently. And I'm going to run the calculation because we also did some improvements on the showing of the results. Okay. And now I'm going to look at the 3D deformations, for example. And once these results are visualized, what I had to do in the past to hide them is drag this little icon into the waste can. So if I don't want to see these results anymore, simply drag the icon into the waste can and the results will be hidden. They're not deleted, but simply hidden. But it was not very intuitive to most of your users. So we also created this cross on the right-hand side, which basically does the same thing as dragging the icon into the waste bin. Another thing we did is from now on, you can also assign a hotkey to the refresh option. So if I make some changements to the result properties, I don't have to hit the button on the bottom of this properties window. I can simply press F5 in this case, and the results will also be refreshed. So yeah, that's also to improve the speed of your workflow. And I can also look for this refresh result instance in the command line and assign a different hotkey to it if I want to. Another thing we did was whenever the results are actually deleted, so you need a calculation. In the past, it was not very clear when that was the case. Because if, for example, I was in the concrete menu, the result icon would still be visible, and I don't necessarily know if the results are present or not. In version 22, you can see this because from now on, not only the icons of the result workstation are grayed out, also the icon itself of the result instance is grayed out. So if I'm in the concrete menu, I can still see there are no results currently because the result icon is grayed out. So it makes it a little bit more easy to see if I need a calculation or not. From version 21.1, the table input is also available again. And we did some improvements on that instance in SCIA 22. I made a little example file of two structures with a different height. And I'm going to use the input table to change the properties of the structure. So it will be, you can find it under tools and then input table. And this is basically a matrix of everything that's inside of your project. If you want to add more entities, you can right click on the bottom bar and add some more options in the input table. One thing we added was a filter option. You can see it here on the right. And if you hover over it and wait a little bit, you can see the filter options that are available in SCIA. And so if you click on it, you can use the equal or lower than or higher than options and fill it in on top of each column to filter on certain cells. So for example, if I want to look for all nodes with a Z coordinate equal to 0, I can simply fill it in the search bar if the filter option is enabled, and I can find those elements, which makes it very easy to change some things in the properties panel again. So if I want to change it to -1 meter, I can do that in the properties window, or might as well do it in the cells of the input table. I can, for example, also look for coordinates higher than 4.5, which allows me to select the roof of the left-hand side structure in this case. If I do the same thing for values lower than 4.5, I select the right-hand side roof, but also the nodes with the coordinates equal to 0, and that's not what I want. So therefore, I can also define a range of values. So in this case, if I do that and select the nodes, by the way, you can select the nodes by clicking on the name of the row in the input table. And by doing this, I selected all the nodes of the roof on the right-hand side. Additionally, we also made some options available in the command line of the input table to do some manipulations. If you right-click on the command line, you can see what are the options. And you can, for example, add, subtract, or multiply the values in the input table. So, for example, if I want to divide the height of the right-hand side building with 2, I can simply add the divide sign, select the cells, and divide by 2 in this manner. Or I can multiply those values with the multiply icon, etc. And you can also see by multiplying, it now falls out of the range that I defined in the filter. So yeah, that keeps on existing, that filter. I can do the same thing for the tall building. If I search for values larger than 4.5, I can select those nodes as well, and I can divide or multiply the value of the cell. One other thing you can do, for example, is use the selected rows only option on the right-hand side. And then if I select some nodes and enable that option, I can only see nodes in the table which are selected. And then again, I can select the cells and add a meter, for example, to lower down or higher the right-hand side part of my roofs. So as you can see, the manipulation options from the command line and the filter options allow me to quickly change some things in my model. Another thing we added was to change the precision of a value in a certain cell. If you select those cells where you want to do this for, and then fill in this icon in the command line, followed by the precision you want, SCIA is going to change the precision of those values you selected. And it can be very useful, for example, when you imported a project from an IFC file or a Revit file. You might know that sometimes you have a lot of numbers behind the comma, which causes some problems in modeling. If you want to change this precision for all coordinates in your project, you can simply use this option in the input table and change the precision. Another thing you can do is search for certain values in the table by typing a question mark followed by the thing you want to search for. So SCIA will tell you how many matches it found. And if there aren't any matches, it will also tell you that. And if you don't want to search in a certain column, you can simply hide the column and then SCIA will search in the rest of the columns. So in this case, no matches are found with this kind of value. Okay, so those things were more graphical improvements or interface related improvements, but we also did some improvements on checks. And the first one I want to show you is the CLT check bit, which we are going to implement in SCIA Engineer. And I made a little example to show you what we already did in version 22. So what we did was provide the orthotropic behavior that comes with a CLT slab. So in this project, I have two slabs which are the same in material and thickness. The only difference is that for the right-hand side slab, I created an orthotropic behavior and assigned it to the slab. What you need to do to be able to do this is enable a timber material. And right at the bottom, you can see the type of timber. In one of the next versions, we are also specifically for CLT adding a CLT type to this material library. But for now, we only have the orthotropic behavior. And you can choose a different type, in this case CLT, and then change some properties to define the stiffness in two directions of the slab. So you choose a number of layers, and you can change the thickness for each layer in each direction. You can also see these shear and torsion factors, which you have to fill in yourself. In one of the next releases, we will be letting SCIA automatically calculate these values, but for now you have to manually define them. And then all these properties are used to calculate the stiffness properties in 2 directions. So the X direction in this case has 4 layers. The Y direction has 3 layers, which means we will have more bending stiffness in X direction, at least for the slab on the right-hand side. And I will show you what or how this influences the results, because now we expect a equal bending moment on the left-hand side for all those 4 steel beams, because we have an isotropic slab on the left-hand side. And you can see this because all values are close to 19. While if we look at the same result for the right-hand side slab, we expect more bending moment for the steel beams that are perpendicular to the X direction of the slab. And that's also the case in this model. So you can see that you can use the CLT orthotropic behavior already to change the stiffness matrix. And in future releases of SCIA, we will be implementing a full CLT check as well. But this is the first step. Another thing we changed in version 22 of SCIA is that from now on, the load where it is visualized will also be the location where it is taken into account in the solver. What do I mean with that? For this asymmetric cross-section, for example, there is an eccentricity between the shear center and the center of gravity. And we show the load, in this case, in the center of gravity, while in the background, we actually take it into account on the location of the shear center. At least that was the case until version 22. You can also visualize this eccentricity if you go to the properties of the cross-section, and it's this dy value of 42 millimeters, which is the distance between the center of gravity and the shear center. So if in reality a load would be applied in the center of gravity, then there should be a torsional bending moment because it lies within a certain distance of the shear center. If I would apply the load in the shear center, then there would be no torsional bending moment in the element in reality. So that was a little bit of a discrepancy in the past version of SCIA, and so we made a change for that. This is also a thing you can set in the solver settings. So if you enable this option, then it will neglect this effect. And if you open old projects, this option will be enabled because you don't want any change in internal forces when you recalculate an old project in a newer version of SCIA. So that's also why there's this option. But I'm now going to show you what is the difference in terms of internal forces. So right now, I enabled this option, which means that the load is taken into account in the shear center, while it is actually visualized in the center of gravity. And so if I look at the torsional bending moments, there is no torsion in this element currently, because of this option that I enabled. If this would be a new project, then this option would be disabled. And now the load will be taken into account on this exact position. So in the center of gravity, which means there's an eccentricity as opposed to the shear center. And if I now have a look at the torsional bending moment, I can see that there's some kind of torsion present in this element. So this actually represents better what happens in reality, because if the load would be on that location where it is visualized, I also get torsion in reality. Last one up are the improvements we did on the concrete design. And to show you, I made a little example of a project with both 1D and 2D elements. And the first change we did was whenever you create a 1D or 2D element, from now on it will automatically have concrete member data attached to it. You can switch between a basic and an advanced view of these settings, but these will always be present from now on when you create a new element or you open an old project, and that for both 1D and 2D elements, as you can see. So by default, these settings will be the same as the global settings. And if you want to show the labels of these concrete member data, you can do that in the view settings. So we have a different setting related to whether the settings are the same or different from the global setup. So if I switch to all in this case, you can see all the labels of the concrete member data of this project, which means there's no concrete member data different from the global setup currently. If I create a new element in this project, it will automatically have some concrete member data attached to it. So let me draw a new beam from this large beam to the slab. And now if I enable the labels of the concrete member data, you will see that there's concrete member data attached to it. It will only be visible when I change the setting to all in the global setup. What I'm going to do now is change the angle of compression strut for shear design, for example, and then switch it back to from different from global setup or concrete settings. And then you will see that only this label is visible. And the reason is because we changed some values in this concrete member data. Let's do the same thing for this 2D element, change the diameter of reinforcement. And you will also see that it gets a different color in the properties window. And now also this label is visualized in your project. So if you now change something to the global settings, it will be applied to all elements which have the same settings currently as the global setup. So I changed the angle of compression strut again, and you can see that it changed it for the long beam. But if I click on the label of the element which I already changed, it keeps the value that I applied to this element. And if I want to reset to global settings, I can use this option on the bottom of the properties window. And now you can also see that all labels disappear for this project. Okay, let's perform a calculation because we also did some improvements to the results. And let's have a look at those. I'm first going to look at the 1D reinforcement design, for example, for this long beam on the right-hand side. And I make sure that I choose a class with both ULS and SLS combinations, because what we did for 1D design is also take into account the cracking and SLS checks in the reinforcement design. Previously, that was only available for 2D elements, but now you can do the same thing for 1D elements. Let's first have a look at the reinforcement design for ULS only. So I disabled the two options in the properties window to have a look at the reinforcement for ULS, which is about 600 square millimeters. And now if I enable crack width and SLS stress limitations, I will see that I need more reinforcement to also cover those kind of checks. So now I will end up with a value close to 1300 square millimeters, as you can see, which means it takes into account cracking and stress limitation. We also added some values, type of values here. So from now on, you can also look at a number of diameters that you need for the required reinforcement. So currently you need 6.2 diameters of 16. So when you start to design this beam, you probably will add 7 diameters of 16. But it's very nice to also see this value so that you have an idea of how many bars that you need to add to this beam. Besides that value, we also have now a total amount of bars needed for the whole section, which is very nice for columns, for example, which I will show you in a minute when we look at the provided reinforcement. Some other options we provided are the weight of the reinforcement in the section, and you can look at that for both longitudinal and shear force reinforcement. So it gives you a good idea whether your design is economic or not. Okay, I'm going to enable the results table. And if you want to see the output of a certain value, you can simply double click on the cell. On the top, you can also see that you can switch between standard and detailed output. And afterwards, you simply click on the value you want to see, and then SCIA will show you the detailed or standard output for that specific value. And as you can see on the bottom, you also have an overview of the total weight that was needed for the shear reinforcement design per volume of concrete. If you switch to required statically, which is the actual amount of reinforcement needed for the internal forces only, you can see we added a delta S serviceability, and this is the amount of reinforcement that is needed additionally for the SLS checks only. So that is crack width and stress limitation. I'm now going to enable the provided reinforcement in the concrete settings, so I can also show you the improvements we did regarding this result instance. And if you now go to this column, you can look at the amount of reinforcement that is needed. This is the same as in previous versions. But now you can see that we also can show the total amount of bars in a column, which is 6 diameters of 16 in this case. And this is easier to understand what happens in the background. And as well, you can also look at the weight of reinforcement for longitudinal and shear force reinforcement for this column. What we also did was provide a unity check of provided reinforcement. So if you have a value higher than 1, you might have to add some options in green here in the provided reinforcement settings to make sure that you have some option to design this column. But for now, it's at 30% of the capacity, which means I have enough options in my template settings for this column. Okay, besides 1D improvements, we also added some 2D improvements regarding reinforcement design. So basically, more or less it's the same as 1D. The crack width check and SLS checks were already present in previous versions of SCIA. So the only difference is that now you can separately enable or disable them. But if you go to the unity check of provided reinforcement, we added 2 more values in this drop-down menu. You can look at the unity check for VRD max, which is the maximum capacity of your concrete with shear reinforcement. And you can also look at VRDC, which is the capacity of your concrete without shear reinforcement. And it makes it very visible where you need to have some shear reinforcement in your slab. So those are actually 2 nice values that are added in the result instance of concrete. So that was about it, what I wanted to tell you about the new things in SCIA Engineer. I hope you liked it and enjoy working with SCIA.